Okay, so let's start this calc prep by talking about the unit circle. Do you guys remember where you start on the unit circle? Right here. And that is 0 degrees. And as you go, hopefully you kind of remember some of these at least. 90 degrees, what would be next? 180 degrees, 270 degrees, and one full rotation would be 360 degrees. Now in calculus, AP, and in college, you're mostly going to deal with radians. So let's review what these would be in radians. So 0 is still just 0. Do you remember what 90 is? Half of pi or pi over 2. So you can write it as pi over 2 or you can write it as half pi. Then 180 would be a whole pi. This would be 1.5 pi. Do y'all remember how we generally wrote that? 3 pi over 2. And then that would be 2 pi. Okay, so you're going to be doing exact values in a little bit, and I want to go ahead and kind of visit this now before we get into the rest of these. But you do those exact values by looking at the points on this unit circle, full of zeros and ones and all of that. And so do you remember what this first point was? Like if you think this is the origin, you're going to the right 1 and then up 0. And the reason this worked out is because the first number was cosine and the second number was sine. And if you wanted to do cosecant or secant, you could modify this, or if you wanted to do tangent, you would do the second number divided by the first number. Up here at 90, that was 0, 1. Over here, this is -1, 0, and down here, this is 0, -1. So you need to be really comfortable doing sine, cosine, and tangent of any of those angles or radians, okay? And if you just drew this on a paper, you should be able to very quickly come up with them, okay? Or memorize them, whichever works best for you. Okay, we also had some angles, though, in between, and I'm going to do that on this other unit circle just because it's getting a little crowded. So there were kind of 3 main reference angles. Do you remember what they were in degrees? And they're kind of down here. 30, 45, and 60. Okay. And we converted to radians always by doing that ratio of 180 degrees to pi. Does anybody remember what 30 degrees was in radians, though? Pi over 6. And so 30 degrees in any other quadrant works just like 30 degrees in the first quadrant, and you would know it's a 30-degree reference angle because it's something over 6. Although in some other quadrants we had negatives. We'll get to that in a minute. And then every time we dealt with a 45, that was pi over 4, or say like 7 pi over 4, things like that. And then 60 was pi over 3. The first time we did this, this was confusing to some of you that you kind of got the 6 and the 3 switched. All right, but by now this should be kind of like more familiar, seeing it a second time, a little bit easier. What was the little thing we used to determine where different trig functions were positive and negative? In which quadrants? Do y'all remember? All students take calculus, or some of you came up with more creative ones than that. And it goes in order of the 4 quadrants. Okay, so in the first quadrant, everything's positive, all. Okay, the S in the second quadrant means that sine is positive. That means that cosecant would also need to be positive, and the other's negative. In the third quadrant, tangent's the one that's positive, so along with it, cotangent. And in the fourth quadrant, cosine and its reciprocal secant are the positive ones. Okay, now it took us a long time to learn this stuff, so I'm going through it pretty quick. But we're not going to be doing the hardest problems we ever did. Before we get to the next one, I do want to remind you guys of the special right triangles. And that is, if you had a 30, 60, 90 triangle, this goes back to geometry. If this is 30 and this is 60, across from the 30 is a 1, across from the 60 is a root 3, and the hypotenuse is a 2. And we called this short leg, long leg, and hypotenuse. 1 root 3, 2. And this is how we did it. Now, and I already kind of talked to you guys this about the beginning of class, but some of these we're going to need to memorize. But if you forget, you can always go back to this. It's time consuming, it's not efficient, but it's something you could do. What about 45, 45, 90? And sometimes they didn't give you the angles, they just gave you something like this. Hypotenuse, or sorry, isosceles, the two legs were the same, so like an isosceles right triangle. And this was 1, 1 root 2. So you really don't need that 45 there. We just had a leg and hypotenuse. No short leg or long leg. And then 1 root 2. And you could set up a proportion. All right. So just a few quick notes. The exact value is always written as it can be written as a whole number or a fraction, but not decimals. And many times it has radicals, meaning root 2 or root 3. The exact value of a trig function is never around a decimal. We do that stuff on our calculator. What we're talking about today is totally without the calculator. All right, and so that's the last note. So these are all ones that you should be able to come up rather quickly over the next few lessons. But I do want to remind you, if you totally forget how to do something like this, the first thing you got to do is put it in its quadrant. Okay? Pi over 6, that's 30 degrees. That goes in quadrant 1. And we would put 30 right here, the reference angle. The reference angle always goes with the horizontal along the x-axis. So across from the 30 is a 1. Then root 3 would be down here, and 2 would go here. And then this brings up the next part of trig, which is the whole SOHCAHTOA thing. Okay, so write this out if you need to. And again, we had several little things that helped us remember SOHCAHTOA. Bless you. So sine of pi over 6, opposite over hypotenuse, opposite would be 1, hypotenuse would be 2. Since this is in the first quadrant where everything is positive, we get positive 1 over 2. Now, I did this pretty quickly, all right? You may not, you may be like, I'm more rusty than that. But eventually, I don't even want you having to go through all of this. Because in calculus, this is step 3 in maybe 10 to 12 steps. This is when the only thing you're having to do is figure out the 1/2. That doesn't seem like a lot of work. All right, but when you're taking calculus, you've got to be able to look at something like sine of pi over 6 and come up with it really quickly. Some of you have already come up with your own little ways of memorizing it, which is totally cool. All right, sine of 0. All right, this is where we need to pick out 0, write the little point, and then sine would be the first or the second number. The second number, so 0. You could also look at the parent function of sine to figure this out. What I'm talking about is this thing. If you're like, that's confusing, then don't do it that way. Everybody's different, so I'm just giving multiple ways. Okay, cosine of pi over 2, that's up here. So what's my answer, 0 or 1? 0. Okay, what's the reference angle on D? Because this is like, this one looks a little bit more complicated, so we can always go back to basics. If it's over 4, it's a 45-degree reference angle. And 3 pi over 4, that would be like 3/4 of a pi. That would put you right here in quadrant 2, and that's important because that's going to determine whether my answer should be positive or negative. So a 45 would be a 1, 1 root 2. Cosine would be adjacent over hypotenuse, so 1 over root 2. And should I leave it like this, or should I put a negative in front? What do you guys think? Negative? Here's the best thing about chapter 13. You can totally leave your answer just like that. It's also good, just for multiple choice reasons mostly, that you are able to simplify the radical, which it would look like this, negative root 2 over 2. Okay, then we get to E and we're like, ooh, cosecant. You got to remember that cosecant goes with sine. It's the flip. We already did, though, sine of pi over 6. That was 1/2. So what's cosecant? The flip of 1/2. 2. Okay, so again, going over a lot of stuff that we haven't done in a while. And now we get to this table. Okay, these are 24 values that you're going to have to memorize. You have to be able to come up with very quickly. You won't have 2 minutes to sit down and try to figure out and draw the triangles every time. Now, if you've forgotten one, you always have that as a backup, but for the most part, you need to know these. Okay, so I'm going to give you a minute to try to fill out as much of this table as you can. Okay? And you may just want to focus on one row at a time or one column at a time, however you want to do it. Okay? Okay, so I want to show you a pattern that develops as we go through this. So sine of 0, we already did that one. That's 0. Sine of pi over 6, we did that one as well. That's a half. Sine of pi over 4, we could write that in one of two ways. 1 over root 2, or if we simplified it, root 2 over 2. Now I'm going to choose this one. Okay, and I'm going to draw a little arrow here. It's totally fine if you write this. We're not going to force you to simplify. I'm writing it this way because I want to show you a pattern. Okay, anybody figure out what sine of pi over 3 was? In a 30, 60, 90 triangle, if the opposite's 1 and the hypotenuse is 2, what happens when you switch over from the 30 to the 60? The opposite would become the root 3. Do you see this pattern here? 0, and then 1, or we could say root 1 over 2, root 2 over 2, root 3 over 2. What would naturally come next in the pattern? We just finished a chapter on patterns. What would come next? Root 4 over 2. Well, what is root 4? 2, and 2 divided by 2 would be 1. And sine of pi over 2, if you do that whole little 0, 1 thing, you get a 1. That's the pattern. This isn't the first time you've seen it. I just think it might be more meaningful to you here. Okay, now I don't go through the other, then it's just the quadrantals here. We get 0, we get -1, and we get 0. Okay, now I'm going to go ahead and do cosine in a different color. Cosine is 0. Anybody? 1? All right, and see how this one is going to go in the opposite order. It's going to go root 3 over 2, root 2 over 2. Again, totally fine if you want to call that 1 over root 2. Doesn't matter. Same difference. All right, anybody, any guesses on the pattern? What should come next? 0. Then what? Look at this pattern. What came after 0? -1. Back to 0. And then 1, because in the end, what should happen is that these should line up because they're the same thing on the unit circle. Okay, exact same. One start, one ends, but same position. Okay, tangent. We could go back through and reinvent the wheel and do all the tangents, but I do want to remind you that tangent is sine over cosine. So if we already have this table sitting here, we could easily come up with tangent. We could just do the first thing divided by the second thing. 0 divided by 1, that would be 0. Or we could look back at a triangle. Okay, the next one would be 1 over root 3. Or if you want to call this, if you want to simplify this, you could. Root 3 over 3. What do you think about the next one? What's root 2 over 2 divided by the exact same thing? Anything divided by itself is 1. The next one's just going to be root 3. Root 3 divided by 1. What about this next one? 1 divided by 0. If you get anything out of this class, this is like maybe the biggest thing. What is something divided by 0? Undefined. But when you do 0 divided by a number, that is 0. So what should go in the next blank? Undefined, and then 0 again. Do you remember graphically why tangent has undefines? What happened on the graph of tangent that did not happen with sine and cosine? Asymptotes, exactly. That's why there's undefined. Sine and cosine, they're never undefined. All right, they didn't have any asymptotes. So these are the ones you have to memorize. They will not be in any particular order like this. Okay, but I think starting with the table and studying this and recognizing the patterns could be helpful to you. Okay, last thing I want to point out about this is I want you to notice that sine of pi over 6 is the same as cosine of pi over 3. Do y'all remember that little thing called co-functions, complementary angles, when we did trig proofs? That is why those are the same. Okay, because 30 and 60 are complementary and 45 and 45 are complementary. All right, enough of that. Let's move on. So you need to memorize those values. I'm not as concerned that you can do secant of 17 pi over 6, but I'm really concerned that you can quickly do those values. All right, exact principal values. This is going backwards, so I want to remind you of something. If you know that sine of pi over 6 is a half, we did that one on the previous page, then do you remember what this little symbol means? -1 in the power? It means inverse, or we call this arc sine. It's backwards. So it's not flipping it. It's backwards. It's saying arc sine of 1/2 is pi over 6. In other words, if I was asking you what arc sine of a half was, I would say sine of what would give me a half. Okay, and if you have some certain values memorized, this is actually really easy. You don't even have to do a graph. Okay, we're always going to be in radians, by the way. Okay, so what this is saying is tangent of what equals 1. I mean, specifically, tangent of what angle equals 1. And now there's this whole deal with restricted range, and we could go into that, although it doesn't seem to be a big deal because none of these are negative, and you learned about that. But if we just look at this table, tangent of what equals 1? Pi over 4. Okay, so that's your answer. Now, if you were just doing this problem from scratch and didn't have a table, okay, you would have to go through, okay, and figure out restricted range, and you'd have to draw a triangle, and you'd have to go, okay, tangent is opposite over adjacent. Both of those are 1. That's a 45-degree angle. Therefore, my answer is pi over 4. That's how we did it before. So I'm hoping you can kind of see the value in memorizing at least some of these. So we did one kind of like this. This is not asking us to take sine of 0. It's saying sine of what equals 0. Anybody know an answer? So it looks like up here, sine of 0 equals 0, sine of pi equals 0, sine of 2 pi. I'm going to tell you, if you just stick with the first answer, you're in good shape. This is where restricted range did become an issue. All right, but if you just pick the first value, you're not even going to have an issue. Okay, cosine of what equals root 3 over 2? Okay, 30 degrees. And you could draw it out. And by draw it out, just for anybody who's like, what are they doing? By draw it out, I mean, draw the triangle, and when you have a positives, you just stay in first quadrant. Cosine would be adjacent over hypotenuse, so we'd do root 3 here over hypotenuse is 2. The 1 would go over here, and you'd say, okay, what is that angle right there? It's 30 in radians pi over 6. What about arc cosecant of 1? This would actually be the very same thing as arc sine of 1. Not because these two things are the same, but when you flip 1, it's still a 1. Right? So what would the answer be? Very good. Pi over 2. Now this is going to throw some of you off because it's not simplified. But remember, 1 over root 2 is the same as root 2 over 2. It's just one's simplified and one's not. One has a radical in the denominator, one doesn't. But they mean the same thing. So what is arc sine of root 2 over 2 or 1 over root 2? Pi over 4. 45 degrees or pi over 4. Okay, so if you look at this homework, there are several. They're mostly going to be in the first quadrant, but not all of them. When you see this number in front of the pi, you've got to consider, hey, my answer might be negative. If you notice on the back, there's a little practice for the quiz. This is your first practice. It's trying to fill out that table without, if you're copying it down from the notes, that's not really going to help you. Okay, so I'm going to advise you not to do that for your own sake.